Good morning, mathematicians. Today we'll be doing lesson 11.1, weight. The objectives for today are to review grams and ounces as units of mass and weight, and to guide the estimation and measurement of weight in grams and ounces. Let's get started with our warm-up. The following two fractions are listed, and I want you to give me a thumbs up if those two fractions are equivalent, or a thumbs down if they are not equivalent. So 1/2 and 2/4. Good, those are equivalent. 1/4 and 25/100. Yes, those are also equivalent. 1/5 and 3/10. Those are not equivalent. Can anyone tell me what fraction would be equivalent to 1/5? Right, 1/5 and 2/10 are equivalent. Alright, our next set, 3/4 and 6/8. Yep, thumbs up, those are equivalent. 4/5 and 9/10. Thumbs down, those are not equivalent. And 2/3 and 3/9. That's also thumbs down, those are not equivalent. Alright, the last set, 14/21 and 2/3. Thumbs up, those are equivalent. 8/40 and 1/5. Thumbs up, those are also equivalent. Whoops. And 12/20 and 2/5. Thumbs down, those are not equivalent. Now we're going to talk a little bit about the difference between weight and mass. So as we think about this, let's first think of a couple questions. The first one is, if you went to the moon and weighed yourself, would you weigh more or less than you do on Earth? Yes, you would weigh less on the moon than on Earth. Turn and talk to your partner about why you would weigh less. We know that gravity is weaker on the moon than it is on the Earth. So now let's think about this question. If your weight on the moon is not the same as on Earth, what does remain the same? Our mass would remain the same on the moon and on Earth. And another question, would you rather have a bowling ball dropped on your toe on Earth or on the moon? And tell why. Turn and talk to your partner about that. Most of us probably said on the moon because the weight of the bowling ball is less on the moon, so it would hurt less. And finally, I want you to turn and talk to your partner and think about an activity where your weight changes but your mass stays the same. Some of those activities could be skydiving, jumping off a diving platform, or riding on an elevator that is either starting to move or coming to a stop. Let's take a look now at the gram, which is a unit of measurement for weight. So if we know that a nickel weighs about 5 grams, we're going to want to think about what objects weigh different amounts of grams. So first let me give you some ideas. So a nickel weighs about 5 grams. We know that one of those tiny centimeter cubes is about 1 gram. A hexagon pattern block is about 10 grams. A compass is about 25 grams. And a calculator is about 100 grams. Look around the classroom right now and think of what other objects might be each one of these values, and turn and talk with your partner about that. Here are some units of measurement that you're going to want to remember. So we can look up here, 1 gram is equal to 1,000 milligrams. 1 kilogram is equal to 1,000 grams, and 1 metric ton is equal to 1,000 kilograms. So thinking about those units, what might be measured in milligrams? Turn and talk with your partner now. One answer for that might be medicine. What else did you come up with? Now turn and talk with your partner about what could possibly be measured in grams, in kilograms, and in metric tons. One possible answer for grams could be food. For kilograms, it could be body weight. And for metric tons, it could possibly be a whale. What other answers did you and your partner come up with? We just looked at the metric units for mass, and now we're going to take a look at some of the U.S. customary units. An object that weighs about 1 ounce is one of our dry erase erasers. 4 ounces would be a calculator. 8 ounces would be like a notebook. 16 ounces would be like our everyday math journal. And 32 ounces would be like our student reference book. So something we'll want to remember is that 16 ounces is equal to 1 pound. Or in other words, 1 pound is equal to 16 ounces. So about the same as our math journal would be 1 pound. Also, 2,000 pounds is equal to 1 ton. Now let's think about what might be weighed in ounces, in pounds, and in tons. Turn and talk with your partner about what might be weighed in each. One possibility for ounces might be letters that you might mail. For pounds, again, might be like kilograms, body weight. And tons might be a truck. What other ideas did you and your partner come up with? Thinking about the units that we discussed today, you and your math partner are going to work on pages 286 and 287 together in your math journals. And make sure to really talk about why you think each one would be the correct answer. So like I said before, we've already done mental math. You and your math partner are going to work on these two together. And then on your own, you're going to make sure you have math boxes 11.1 and 11.2 finished. And then everybody will be moving on to Activity B, Blend Space Unit 11 and 12, Activities A and B. Make it a great day.